Hi and a very good morning to all of you. Today we'll be doing a lecture on surface area and volumes. This is a topic of class 9th, right? And it is very important from the point of view of final examination and competitive examinations alike, right? So in this lecture we'll be basically discussing about the formulas, right? How do we come to various formulas of the 3D figures? Clear? So let's move on. The first figure, or the simplest figure we'll be discussing, is a cube, right? You all must seen what is a cube in your daily life. It can be a sugar cube or it can be an ice cube. For example, let me make a 3D figure. Something like this, right? Now I've drawn a cube for you. Let me quickly name all the vertices of the cube. Right? Now as you can all see, what is a cube? That it has 12 edges, right? 8 vertices and 6 faces, right? Now the faces, for example, D, C, G, H, A, B, C, D, A, E, F, B and so on. Now all the 6 faces are what? Squares. Clear? Now let us write the first formula, that how do we calculate the volume of a cube. Now please note that all those 3D figures which on contact with ground make an angle of 90 degree. Clear? Let me repeat again. All those figures, 3D figures, which on contact with ground make an angle of 90 degree, as you know that these all are squares, so they will make an angle of 90 degree. So their volumes is always what? Area of base into height. Clear? Now again you can notice that since all the faces are squares, right? So if I take this length as S, EH will also be S and AE will also be S. So area of base, side into side, right? And into H, that is also S, so it comes out to be S cube. Clear? That is side cube. Now we come to the next formula. The next formula we calculate is called LSA, or in this case it will be rather called as CSA. Oh, I'm sorry again. It will be called what? LSA, lateral surface area. Now, what is a lateral surface area? If I exclude the top and the bottom faces of the cube, right, I'll be left with 4 faces, right? And the lateral surface area of those 4 faces, which are actually 4 squares of same side, will be 4 into S square, or 4S square. Clear? Now I take the next term as TSA. TSA is in short for total surface area. Now area of one square is what? S square. And how many similar squares are there? 6. So 6S square. Clear? Now we can be given one case where we are given a cubical box which is open at the top. A box open at top, which means now A, B, C, D face is not given, rest all 5 squares are given, so their area will be 5S square, right? These 4 are basic formulas. Now we will proceed to very important part of a cube. Clear? Please listen it down very carefully. Now let me rub okay, LSA and TSA will be more than enough. Now we have to calculate the diagonal of a cube. Clear? What is the diagonal? The diagonal of a cube is given as root 3 into side. Clear? How? Now how do we get this? Diagonal is equal to root 3 into side. Now in a cube, a diagonal is the largest distance we can measure. This. If I join BH and F and H, I get a right angled triangle which is right angled at F. Now I write in triangle BHF, right? The diagonal of the square is what? Root 2 times into side. So I'll write BH square is equal to square of root 2 into side plus BF square, that is what? Side square. I simply applied Pythagoras theorem here. Now I get BH square is equal to root 2 square 2s square plus s square. That gives me thrice of s square. Right? Now this root 2 will get transferred as square root and I'll get what? Root 3 into side or root 3 times side. I hope it is clear. Now some very good questions come where you are given only the diagonal and you have to calculate the volume of the cube. Clear? Now how do you do that? First of all, we take side from here. Side will come out to be, here root 3 is multiplied. If we shift it to there, it will become what? Or divide 2. Now what is volume? Side into side into side. So we simply cube the side and we get d cube by 3 root 3. Right? This will be our final answer. So if diagonal is given, we can very well calculate the volume of the cube by applying d cube upon 3 root 3 formula. Right? I hope it is clear to all of you. Now moving on to the next figure. That is a what? Cuboid. A cuboid is almost identical in terms to a cube as it has all these three qualities, which is 12 edges, 8 vertices and 6 faces. So let me quickly draw a cuboid. See, my drawing is not very good, so I try my best. Right? Well, it will be some sort of a fish tank example. Right? And here. The only difference is that all the 6 faces are what? Rectangle. Clear? Now, let me again quickly name all the vertices, that is A, B, C, D, E, F, G and H. Again, what will be the volume? The volume will be area of base, right? Now into height. Now as you can see that all the faces are what? Rectangle. So let this be L, length, and EH be what? B. Now since these are 3-dimensional figures, this will be what? H. L, B and H. 3 dimensions of a 3D figure. Now what will be the volume? Area of base. What is base? A rectangle. Its area will be L into B into height simply. So L, B, H formula. Now what we have to calculate? We have to calculate the lateral surface area. Why I am not writing a CSA, that is curved surface area? Because none of the side of the cuboid is curved. Right? That we will discuss in what? Cylinders and cones. Clear? So what will be the lateral surface area? If we exclude the bottom and the top face, we are left with 4 triangles. Clear? Now, sorry, rectangles. Now first of all, let's look at this face. D, C, G and H. D, C, G, H. Its area will be L into what? H. Now a similar face is given at the back of the cuboid. A, B, F, E. Its area will also be same, L plus LH plus LH. Clear? Now this face ADHE, its area will be what? H into B. Now similarly this face BCGF, its area will also be H into B, and we add these. Now we get twice of LH plus twice of HB. What we can take out common? 2 and H. So we get twice of H into L plus B. And this comes out to be our lateral surface area of the cuboid. 2 times into height common into L plus B. Now this can also be written as the area of 4 walls. Clear? In some questions, rather in most of the questions, if you're given a cuboidal room and you have to paint all the 4 sides of the room, you need this lateral surface area, or what we call as the area of 4 walls. Right? I hope it is clear. Now, moving on, third term we calculate, that is what? TSA, total surface area. We already got what? Twice of LB, twice of LH plus twice of HP. Now we need to include those 2 faces which we left, that is the top and the bottom. Now the area of the bottom face will be what? L into B. Similarly will be the area of the top face. So twice of L into B. Now we take out 2 common, we are left with what? LB plus BH plus LH. And this comes out to be our total surface area, the lateral surface area, and the volume. Clear? Now again we'll have to find out the diagonal of the cuboid. Clear? Again similarly, BFH triangle, which is right angle at F. Clear? Now meanwhile try to find it out yourself. We know that the bottom face is a rectangle. The length of the diagonal of a rectangle is what? Under root L square plus B square. Again, let me write it down. In triangle BHF, we have to calculate BH square is equal to under root L square plus B square whole square plus BF square. What is BF square? That is H square. This root will get cancelled with this square and we'll get BH square is equal to L square plus B square plus H square. Right? Now we'll take this square as the root on the left hand side and we get the formula for the finding out the length of the diagonal of a cuboid, that is BH. Right? I hope it is clear to all of you. So now we come to a third figure, that is what? A cylinder. Right? What is a cylinder? I'll draw a 3D diagram of it. Right? By default, we have to take every cylinder as a right angled cylinder, since unless it is not mentioned. Right? This will be what? The R, the radius of the cylinder, and this will be what? The height. And this will make an angle of 90 degree on both the sides. Clear? Now, to explain you, right, the volume. Volume will be what? It makes an angle of 90 degree. So pi r square, since the base is a circle, pi r square into h, or the capital H as we have taken here. So area of base, that is a circle, pi r square into height, as I told you before. Now we have to calculate its LSA. I have a sheet to show you how we calculate the LSA. For example, I take this sheet, right, and I fold it like this. Clear? I fold it something like this. Now this face is what? A circle, right? And this face is also a circle. Now if I open my sheet again, this side becomes a circle. Clear? So its circumference will be what? 2 pi r. And this, the breadth of this rectangular sheet becomes the height. Clear? So the LSA will be what? 2 pi r into what? Height. So 2 pi r h is the LSA of the cylinder, or rather we can call it CSA. Again, the TSA, or the total surface area of the cylinder, always the curved surface area plus. Now what we need to add here? We need to also add here the areas of these two circles, right? The area of one such circle will be pi r square, and two such circles will be 2 pi r square. What we can take out common? 2 pi and r. We'll be left with h plus r, and this is the formula of the total surface area of the cylinder, right? I hope it is clear to all of you, right? Moving on, we'll now move to our cone, the fourth figure. As you might have seen in childhood, or even till now, you can see a cone is something like this, right? Again, the base is what? Always a circle, and it makes an angle of 90 degrees. We can name it A, B, C, and this point as D. Now, what we'll do, we'll calculate first of all the volume, or as I always write the volume with a blue pen. So volume will come out to be as what? 1 by 3 pi r square h, right? This is r and this is h. Now see, you have to learn it as it is, cause to find this out we use integration and differentiation, which comes in our class 11th and 12th. So the time being you can learn it as it is, right? Now we proceed on to the curved surface area, since this ABC is actually a curve around the circle. Now the curved surface area we calculate it in terms of slant height, L. What is this L? This L is actually AC and AB. Clear? We call this L as our slant height. Now you can ask, how do we find slant height? Again, it is a right angle triangle, triangle ADC, right? AC square is equal to AD square plus CD square. So if we do this, we get AC square is equal to CD or DC square, that is R square, plus AD square, that is H square. This root, this square, will shift onto the RHS and it becomes under root of R square plus H square. So we can find out slant height if we are not given, but if we are given radius and height of the cone. Now, how do we calculate the total surface area of the cone? The total surface area is what? Pi RL, always the curved surface area, plus the area of the base, that is a square, pi r square, and it comes out to be, we take pi and r common, L plus r, pi r into L plus r, and this is the volume, right? I hope it is clear to all of you again, right? Now, proceeding on, the last figure we have is that of a sphere, A sphere is the most common object, 3D object you might be seeing from childhood. That is what actually a ball, a curved ball, or rather a totally round ball, or a globe is what a sphere. The figure is something like this, but it is 3D. So consider this cross section as also square. Or rather, I should make it a little bit more curvy, right? And this will be the center O, and this will be what? The radius. O, and you can name this point as P. OP is R, the radius. Again, the volume we calculate it out by using calculus in class 11th and 12th. For the time being, you can learn the formula for the volume of a sphere is what? 4 by 3 pi r cube. Clear? It's CSA. See, I always get confused, right? CSA and TSA is always same. That is 4 pi r square. Again, you have to learn it out as it is. Right? These two things, rather, since the curved surface area and total surface area is same, you have to learn these two things about a sphere. Right? I hope it is clear to all of you. In this lecture, I have told you all the basic formulas we need, right, to calculate the questions based on surface area and volumes. In next lecture, we'll be moving on to the actual questions that come in final examinations and competitions alike. Right? I hope you like this video. Please share, like and subscribe. Thank you.